So this is problem number 5 from the AP Calculus AB for your response. I'll give you a moment to read the problem and then I'll work through it. Okay, so this problem gives you a graph, and it's really important to understand whenever you're given a graph in the AP exam, what you're given a graph of. So right here it says you've got the graph of the derivative. They tell you some information about this graph. The derivative is twice differentiable, the function is twice differentiable, which means both the first derivative and the second derivative exist everywhere on the interval from -3 to 4. The graph of f prime has horizontal tangents at x equals 1, x equals -1, and x equals 3. They're just clarifying that what you see in the picture is actually true. The areas of the regions bounded by the x-axis in the graph of f prime on the intervals from -2 to 1 and 1 to 4, 9 and 12 respectively. So this area, they say, is 9. Now keep in mind, it's actually below the x-axis, so if I were finding the area, it would be -9. And this area is 12, but it's also below the x-axis, so that would count as a negative area as well. All right, so for part A says to find all x coordinates at which f has a relative maximum. So whenever you're actually finding relative extrema, the first thing you would need to do is find f prime. Well, you're given a graph of f prime right here. So once you find f prime, you make a sign line for it. Now on that sign line, you put all critical points, which are places where the derivative equals 0 or is undefined. So if you look at this picture, the problem tells you that f is twice differentiable, so the first derivative is never undefined. But there are 3 places where it equals 0, at 2, at 1, and at 4. And I circled white on white so it doesn't really show up. So I'm going to put those numbers on my number line. And then I need positivity and negativity. So if I look at the graph, it's above the x-axis to the left of -2, and it's below between 2 and 1, sorry, -2 and 1, and it's also below between 1 and 4. When I'm looking for relative maxima, positive derivative means it's increasing, negative means decreasing, negative means decreasing. So the only relative max you see is at x equals -2. Now it's really important when they say give a reason for your answer that you give the justification that we talked about earlier in the year, which is the derivative is positive to the left of -2 and negative to the right. So please make sure anytime you're justifying for relative extrema, you give that justification. So that's part A. Part B says on what open intervals contained in -3 to 4. By the way, open intervals means, right, not including the endpoints. Is the graph of both f both concave down and decreasing. So you've already answered the decreasing part of this by making the sign line in part A. I'm going to go ahead and rewrite it just so I can see it again. You don't have to do that, obviously. I don't really care about this part. So it was increasing, decreasing, decreasing. And then, in order to find concavity, I need to know about the second derivative. So this was the first derivative. This is the second derivative. The second derivative is the derivative of the derivative. So I'm looking for places where the slope of this graph changes sign. So if you look, the slope changes sign right here, which is at -1, and right here, which is at 1, and right here, which is at 3. So I'm going to put those numbers on my number line for the second derivative. So -2 was not one of those numbers. -1, and 1, and 3. Now, when I look at the slopes here, the slopes are negative, then positive, then negative, then positive. And again, I don't care about anything past 4, so I'm just going to ignore anything past 4. So I was looking for things where it was decreasing and concave down. So I can ignore anything below -2 because it's increasing there. And when I look at this decreasing part right here, starting at -2, it's also concave down up to -1. So I have an interval, and it's an open, remember, so you don't have to include the endpoints. From -2 to -1 is one place. As soon as it hits -1, the concavity, by the way, remember, like that. When I hit -1, the concavity becomes up, so we ignore that. When I hit 1, it goes back down again, and the function is still decreasing. So I would include this interval starting at 1 and going up to 3. And then as soon as I hit 3, it's concave up again, so it doesn't fit the category. So these are the intervals, and it says give a reason for your answer. If they're saying they want it to be both concave down and decreasing, that would be because f prime of x is negative. That causes the decreasing. And f double prime of x is negative. That causes the concavity to be down. So, part C. Part C says find the x-coordinates of all points of inflection for the graph of f and give a reason for your answer. Well, since we've just done the sine line for the second derivative in part B, we don't really have to do any more work. It's right there. So if you look at this sine line for part B, what you're looking for with points of inflection, and this is super important, is you want the places where the second derivative actually changes sign. Saying the second derivative equals 0 means nothing for points of inflection. It actually needs to change sign. So when I look at this sine line, I see that the points of inflection, places where the second derivative changes sign, happens at -1, at 1, and at 3. And it said give a reason. And the reason is f double prime of x changes sign there. Not just because it equals 0, because it changes sign. So that's part C. Part D. Now part D says, given that f of 1 equals 3, write an expression for f of x that involves an integral. And we've talked about this, right? When you take a definite integral of a rate of change, that actually gives you the change in the function itself between those two values. It's kind of the idea of taking the definite integral of a velocity gives you a displacement. It's a change in location. So that would give you the change in the function value. If I then add that to the original function value, that would give me the new function value. So it looks like this. If I want to get to f of x, I would start at f of 1, because that's what I'm given. It's 3. And then I would add to that an integral that goes from the place I'm sitting right now, which is x equals 1, to the x value that I want to find. So let's call that x. And then I would be taking the definite integral of the derivative. Now be careful, because the way these accumulator functions work, you don't want this variable and the variables in the integrand to be the same. You need dummy variables to act as placeholders here. So instead of writing f prime of x here, I'm going to write f prime of t with respect to t. Now, if you had written this as f of x equals 3 plus this integral, that would have been just fine as well. So this is actually all they're asking for right here. This is an expression that involves an integral. Now, I wrote it as an equation, but the expression here is what they're looking for. Then it says to find f of 4 and f of -2. So if I find f of 4, that means I would start with f of 1, which is 3, and I would add the integral from 1 to 4 of the derivative, right? So if I look at this integral here from 1 to 4, that integral from 1 to 4 is this area, which is the reason they gave you that in the beginning of the problem. So keep in mind, because that was under the x-axis, the area would have been -12. So that means that this is 3 plus -12. So f of 4 is -9. Likewise, if I'm doing f of -2, now be careful here. I would have started at f of 1, which is 3, and I'd be adding the integral from 1 to -2 of f prime. Now keep in mind, whenever the bigger number is on the bottom, like it is here, if you reverse the endpoints, that actually changes the sign of the integral. So what I'm going to do here is I'm going to reverse the 1 and the -2, so I have the bigger number on top and the smaller number on the bottom. but that changes the sign of the integral. And now, when I look at this graph, the integral from -2 to 1 is this region right here, which was -9. So this is 3 minus -9, which is 12, and that's what f of -2 would be. So this is problem number 5.